Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today ends our unit, Unit 5, and we're going to end it by having a lesson on graphing two variable inequalities. So we've already graphed single variable inequalities. That would be something like x is greater than 4. And if you had a graph, right, you would mark 4. Open point because it's not greater than or equal to, it's just greater than, and you would draw it to the right because numbers like 5 and 6 are all greater than 4. So any number to the right of 4 would work. Now we're going to graph two variable inequalities that have two variables, right? By definition, two variable inequalities are going to have an x and a y. So we're not going to graph them on a number line, we're going to graph them on a coordinate plane. Before we start graphing the inequalities though, let's do a quick intro with graphing a line. So graph the equation y equals 4x minus 3 on the coordinate plane below, and then we will start our discussion with inequalities. Okay, so we have a line where the y-intercept is -3. So we can put a point there. And if I can count my change in y over change in x because the graph is ticked off by units. So I'm going to go up 4, change in y over 1, and here is my new point. I then can draw my line between them. Okay, the next question is, what do the points on the graphed line represent? So we can just label some of these points. Take a minute to think about what they represent. All those coordinates on this line. And if you want to label some more, you can. Although that's not the right one. Well, all these coordinates represent solutions to the equation. Let's just take the point 2, 5. So if I have the original equation, y equals 4x minus 3, and I look at the equation at 2, 5, well, 2 is my x value, 5 is my y value, so we can substitute both of those in. I get 5 is equal to 4 times 2 minus 3, so I get 5 is equal to 8 minus 3, I get 5 is equal to 5. Right, that point makes the equation true. And if you did that with any point on the line, let's just take another one. Let's go at 1, 1. Well, I'd get 1 is equal to 4 times 1 minus 3, which is equal to 1 is equal to 4 minus 3, and 1 is equal to 1. And you could test that an infinite amount of times with any point on the line, and you would see that the equation is true. If you tested the equation with a point that's not on the line, right, we could just, let's test it with this point right here. -4, 1. Well, I'm going to get 1 is equal to 4 times -4 minus 3. I get 1 is equal to -16 minus 3. And I got 1 is equal to -19. Well, that's false, right? But it makes sense. It should be false because that point was not on our line, so it shouldn't make the equation true. So again, just a relationship between the points on the line and the equation. Let's take a look at what's below. It says list pairs of coordinates that make the inequality below true. Graph them on the coordinate plane above. So I'm going to get rid of this point. Going to get rid of all this because I'm going to be working up here. I don't want to get rid of the graph. But you guys can just do your work below. So see if you can find numbers for x and y that make this inequality true. Write as many as you can down in, let's say, 2 minutes. Go. Okay, so I'm just going to take the point. Again, I'm doing the second question. I'm just going to do my work up here. So I'm going to take the point 4, 20. Let's see if well, you know what? Let's do points that are I can actually graph. That would make more sense. Let's do -2, 0. So when I have that, my inequality becomes 0 is greater than or equal to 4 times -2 minus 3. I get 0 is greater than or equal to -8 minus 3. And I get 0 is greater than or equal to -11. Well, that checks out, right? 0 is greater than -11. It's not equal to, but greater than or equal to makes sense here because all it has to be is one of those, right? It can be greater than or it can be equal to. So if I plot that point, -2, 0, it falls right here. Let's do another one. Let's choose -1, 3. -1, 3. So I get 3 is greater than or equal to 4 times -1 minus 3. I get 3 is greater than or equal to -4 minus 3. And I get 3 is greater than or equal to -7. Again, that checks out. That works. So we can plot it. Let's do 2 more. Let's do -6, 6. So I get 6 is greater than or equal to 4 times -6 minus 3. I get 6 is greater than or equal to -24 minus 3. And I get 6 is greater than or equal to -27. Also true. -6 is greater than or equal to -27. So I can plot the point -6, 6. Well, you may ask, Mr. Fawcett, it looks like you're plotting points on the same side, or you're just picking points on the same side of that line. Fair enough. Let's pick a point on the other side. Let's pick the point 6, 0. So that would be right here. Well, if I have 6, 0, I get 0 is greater than or equal to 4 times 6 minus 3. I get 0 is greater than or equal to 24 minus 3. And I get 0 is greater than or equal to 21. This is false, though. 0 is not greater than or equal to 21. So I actually shouldn't plot this point, right? I only wanted to plot points that worked. So you could keep going, and maybe your points were different than the ones I chose, right? But they should have all fallen on this side of the line. Or they may have fallen on the line, right? Let's actually test one that is actually on the line, because we've tested some on both sides. Let's test one that's on the line. Let's just test 1, 1. So I'm going to get 1 is greater than or equal to 4 times 1 minus 3. I get 1 is greater than or equal to 4 minus 3. And I get 1 is greater than or equal to 1. This is true. 1 is greater than or equal to 1 because it is equal to 1. So this point works. So what you would find is that any point on the line works, and any point to the left of the line works for this inequality right here. So if I wanted to represent all the points that worked, I'm not going to sit here and plot every single point that I can, right? Because I'd be here forever. I'd have to plot every single point on this side, even the decimals, even the fractions, and I would just be here forever. So what we can do is just shade the side of the line where the points all work. That lets us know that I'm including all of those points as solutions. So basically, we just have to go one step further than graphing a line. The first thing we would do is we'd make our inequality an equation, and we'd graph the line, right? That's why I actually had to start off by doing that. Then you would go back to your inequality and choose a test point, right? You choose a test point on one side. We chose many test points here. Let's just look at -2, 0 up in the left-hand corner. -2, 0 is right here. It's on the left-hand side. Because that point worked, that's the side we would shade on. If you had chosen a point on the other side, right, like when we chose, I forget what we chose, I think it was 6, 0 or 7, 0. If you chose this pink point, you would figure out that that point doesn't work in our inequality down here. So we would not shade that side, we would shade the other side. This is essentially what this lesson is, right? You now know how to graph an inequality. We are going to go through one or two examples, though, just from scratch to make sure we're on the same page and get you some time to practice. But this is all the new material that we're learning for this topic. I guess there is one other thing I haven't gone into as much detail for. Let's do the second one. Y is greater than 2/3 x plus 4. So again, the steps. First, just make this an equation so you can graph the line. Because you need that boundary line. That's what we call it for a two-variable inequality. That boundary line separates the solutions from the non-solutions. So right here we have a y-intercept of 4, a slope of 2/3, so change in y is 2, change in x is 3. That brings us a new point right here. And I can sketch. So I have my boundary line. I know my solutions are either going to be above or below it. To figure out which one that is, we choose a test point. So I'm just going to choose a point. A lot of times 0, 0, the origin, is the easiest test point to choose because it's very easy to substitute in 0. Just make it a little bright there. Okay. So now you're using your inequality. So we're going to test the inequality at 0, 0. That means I get 0 is greater than or not than equal to, just greater than. Greater than 2/3 times 0 plus 4, which gives me 0 is greater than 0 plus 4. 2/3 times 0 would be 0. And then I get 0 is greater than or equal to 4. But this is false. 0 is not greater than 4. And I hope I didn't say greater than or equal to, just greater than 4. Because this is false, we are going to shade on the opposite side of that test point. So we are going to shade up here. Every single point above the line would work, right? And just to prove it to you, you don't have to do this because you've already done a test point, but just to show you that this will work, let's choose this point, -2, 4. So if I have my inequality, at -2, 4, I'm going to get 4 is greater than 2/3 times -2 plus 4. This is going to give me 4 is greater than -4/3 plus 4. Again, if you multiply a fraction by a number or by a whole number or an integer, you multiply the numerator by that integer. Now I have two things to add on my right-hand side, right? I have a fraction and a number. I need to find a common denominator. Common denominator here is 3. So my first fraction doesn't change. And remember, this 4 is really like being over 1. So if I'm multiplying the 1 by 3 to get 3, I've got to multiply the 4 by 3 to get 12. Then if I simplify, I get 4 is greater than 8 thirds. And you could punch this in a calculator, right? I think we know that 8 over 3 is less than 4, which makes this true. But if you punch it into a calculator, you get 4 is greater than approximately 2.6, well, exactly 2.66 repeating, or 2.67 approximately. So this is true, which makes sense because it was on the side that we shaded, right? Just like any other point on that side, it works for the inequality. Now, the very last thing is this inequality was just a greater than. There was no equal to sign. So we need to go back and think about the points on this line. Do the points on this line work? Well, let's see. Let's look at one of them, 0, 4, and let's test. So at the point 0, 4, that is on the line, I get 4 is greater than 2 thirds times x plus 4. I get 4, not times x, we know that x is 0. I get 4 is greater than 0 plus 4, and I get 4 is greater than 4. Well, this is false, right? 4 is not greater than 4, it's equal to 4. So whenever we have a sign that does not include the equals part, we have to put a dashed line. And all this does is show that the points on the line don't work, right? Only the points above the line here work. So we still need a boundary line to separate the solutions from the non-solutions, but we're not going to count the points on the line because they don't work for the inequality. The points on the line will only work for the inequality when you have a greater than or equal to inequality, or less than or equal to inequality. Okay, let's finalize some of this stuff on the next page. We have a box where we're just going to put down the most key things, and then we're going to wrap this video up. So the rules for graphing two-variable inequalities. When the inequality is less than or greater than, we used a dashed, let's make that a little smaller. We used a dashed line for our graph, a dashed boundary line. This is because the points on the line do not make the inequality true. On the other hand, when the inequality is, it's fixed on your page, but it's certainly not fixed on mine. When the inequality is less than or equal to, or greater than or equal to, we use a solid line for our graph. This is because the points on the line do make the inequality true. And then to figure out which side to shade on, we use a test point that is not on the graphed line. If the test point makes the inequality true, then we shade on that side of the line. If the test point makes the inequality false, we just shade on the other side of the line. Okay, we've now covered all the different rules for graphing two-variable inequalities. There are some more problems in this packet. We'll work on them in class, or you can get started with them on your own. As always, thank you for watching. Enjoy your day, and I look forward to seeing you next time.